So, thank you everybody for now. We will go for our third talk, from problem to production, DevOps for AI with Kubeflow.
Yes, I want to present Fabrizio. He's a managing consultant at Wavestone. He is a CNCF ambassador, so he's a great fit for today. And he has also written a book recently, so high-profile people here.
And next to me, somebody that tries to make also a little bit of fun in that talk. Sometimes funny, mainly ML engineer and father. Not much time for that left, but for that we have talks like this. This is Crisafulli, and we know each other for a couple of years and always got sometimes something in common that we want to present or something.
So I improved the model. It has 99% accuracy. Yay!
It's broken. Wow. Now it runs again, but now we have again the bug, the old one that is really bad, and we already solved in version 1. I think quite common, and also big companies showed this is really common.
Yes, a lot of companies and people face some difficulties when working with machine learning. This has to do with scalability, reproducibility, and also why Fabrizio is here today, aligning stakeholders. Today, we will not solve every AI problem. I think that's impossible. We will also not show you how to be better than Google. I think this is also impossible, at least at AI stuff. And we want to understand, or give you the impression to understand a little bit your company, what you want to achieve with machine learning, and we want to show Kubeflow. It's a tool for MLOps. What MLOps is, we will talk a little bit about this.
But before we dive into Kubeflow, let's look at where we use it and which problem we want to solve with AI. It came already in both talks. It was at least mentioned really shortly, right? And I think everywhere it is. Mainly also top-down, as it looks like. And there we really want, before we ever go into any tools, we want really to go into that you always ask these questions, right? What is the business problem that you try to solve? Can we measure it? We both had with multiple customers, like, we need AI, we want it, we know the project, and then we ask, okay, how do we measure if we are successful? And often they were not able to answer that. So really core questions. No tool will solve this problem if you don't start really with that benefit at the beginning and the necessity, and also if it's able to do, right? Before we had an insurance here, laws and the regulations, compliance need to be still in place, and AI has there also its limit what's possible at the moment. And also not always it's beneficial just because you can also add AI to a problem. And for that, it's really important that always at the beginning we look first at how can we qualify a business problem. We use really some defaults that you already know from requirements engineering. Don't forget, just because it's AI, it's not, again, like crypto, right? Think about how are the benefits there? How can we really measure the benefits? And is it what we currently need? Is this, maybe we can use something like a Wardley map to really look, is that the next feature, the capability that we need in our app that we really have to add next? Afterwards, that we know a little bit where we want to go to, we should really look that we align with stakeholders and also business. What do we want to do? There we can do something like domain storytelling or a visual glossary to really bring all together in the room. So really business and IT stakeholders into one room and say, hey, how do we get to this point? And that everybody understands the same. Not that we build something that works perfectly, but it doesn't solve our initial problem. And at the end, the tactical design. So if you are a big company, how do we split our big problem into multiple applications so that teams can work independent, as we just discussed before, right? That we really have these borders. They should still talk a little bit, but we try to decouple these teams that they can work independently and all know what each team is doing which capabilities and where their responsibilities are. And now, getting started with the project after we know what we want to do.
Right. We have this typical 4 phases of project. Everybody knows it a little bit. We have proof of concept at a very first validation of your problem, and then MVP, and it stacks on top every time you go a step further, like regulation, SLAs, quality and stuff. And here in Crisafulli, the Gartner AI awareness labels that you can add to these phases, I would say most of the time we are a little bit in this either proof of concept or MVP. Like you want to do something, you want to validate if it works for you, and except in AI you need to watch a little bit for data quality. Like if you go with an LLM, you don't need to do a proof of concept. The concept that an LLM works is already here. You need to look if it works for your data, for your use case. So already when you do AI, ML in your company, you most probably are already in MVP, because the concepts are mostly proven for different workflows.
On the other hand, really ask, what do we want to prove if somebody says, yeah, we need an MVP, a POC, we don't need an MVP. And ask them if they know the difference. Yeah, and then we have product strategy, and at the end, the scaled approach. And as Marco said, right, somewhere here, data quality comes in, not at POC. And here where we have the data quality, we want to look that it's consistent, and if we have changed, that we know why the data changed and that we can reproduce these things. And for that, we can now go from the concept to the implementation. So we have our data, we load it, we do some Python, and then we do the magic and we have AI, right? Unfortunately, not always. And what we see is, we talked before about DevOps tool, a lot of people are here struggling in bringing that to production. And this is an analysis that shows how many companies are really using how much time just for the model deployment. And this statistic, it was 2022, we didn't found a newer one, was really like, hey, only a small part is using less than 25%. The most are using more, right? There are even some claiming 75%, more than 75% of their time just for the deployment. And this is too much, right? We need here something like DevOps for machine learning and AI use cases.
And there comes the term MLOps. It's like all these ops frameworks, it's like DevOps a little bit, but machine learning has some interesting stuff in it that needs a little bit another approach. In this MLOps framework, we separate 3 different types of steps you need to do. Everything that has to do with data. This concerns stuff like data loading, transforming, train test splits, this kind of stuff. Then the model. There is how to design your machine learning models, hyperparameter tuning, evaluation, all this stuff are in the model part. And the code part concerns inference, like how is your machine learning model used by another application. And machine learning has this anything changes everything principle, so something changes and you need to do the whole loop again. Like if you have in inference some kind of model or data drift, quite common stuff, then you probably need to look again at new data. So you start over from the beginning. We have here a look on a more detailed view, we have these 3 pipelines, as said. All of these needs or benefits if you automate it. Like if you have this data preparation, splitting, automated, then you can do it over and over again with fresh data, with more data, and so on. Then also this machine learning pipeline, you want to test automatically. Like, is a new model really better regarding your splitted data, your validation data? And you want to deploy automatically. These 3 pipelines are commonly known as machine learning operations.
So, and now we saw how MLOps work. Now let's look at how we can use it in Kubernetes with Kubeflow as a framework. Kubeflow is an incubator project of CNCF, and it's quite commonly used. As you see, it's one of the most used incubator project, right? Incubator is not like the really mature project, but it's like one of the newer not a sandbox state. That's the really early one where you probably should look, do you really want to use that in production? Incubator, normally you can start adding it to production, but they will not yet guarantee really long time support in the incubator phase. But you see already, like of the asks in that survey that was in 2025, already 10% were using it in production and 11% were using it in evaluation. So you saw a lot of usage, for example, quite as similar as Backstage, and OpenTelemetry, for example, is also, as it's already used, quite common, still an incubator project. So you see there, it has some good company in here. So, and who uses Kubeflow? You see mainly it's used in the technology sector, a little bit in finance, and the rest is a little bit spread over the rest. And you see it's all over the world used. That's normally a good sign, right? It's not like sometimes you see in some CNCF project, they are really just to one region focused, but it's really a widespread in geography and also over sectors, industry sectors. So what is Kubeflow? Kubeflow is really just an assemblement of many features that you can use also independently. That runs on Kubernetes. So with running on Kubernetes, it means right in the cloud, most clouds, and also on-prem or self-hosted. And then you have a lot of components, and they are all really, you can use one, you don't need to run all. But you also see for that it is an opinionated framework. Maybe who knows also Knative, that's a similar thing. You will install it and it will be a lot of components and a lot of things that you can do. And they have an opinion on how to do that because they have everything out of the box. But you can also start small with just 1 or 2 components.
Wait a little moment. A funny thing, this Kubeflow Pipelines has no logo at the moment, but it's the most mature one of it all. If anyone knows Vertex AI from Google, that's the hosted AI offering of Google Cloud, this uses Kubeflow Pipelines underneath. This Kubeflow comes from Google initially. That's also a little bit why it's complex, has a lot of components and needs 3 nodes just to run, but it's cool. A little bit, this is the same graphic as before, but now with Kubeflow components. We are aware of that these roles are a little bit arbitrary. Also, most companies don't have a data engineering team, a data science team. Mostly it are 2 or 3 the data guys, and they do all that stuff. But for completion, we did a little bit which role is intended for which step. Like data engineers, as we told, ETL, gathering data, transforming. For that, there's a Kubeflow operator, Spark operator. If someone wants to do Spark, has a lot of data, Then it goes to the more data science-y roles, like training a model, evaluating it. For that, the Kubeflow trainer, that's a module to make multiple training runs side by side in Kubernetes. And a model registry, a trained model, an evaluated model will come into a model registry, so they are comparable to previous runs and stuff like that. And the idea is that a software engineer takes out a model from the model registry and deploys it in a way that an application or your application can use it. This is typically done with Kserve in Kubeflow. Also, here is this typical training inference line, like these are periodical but countable steps, like you do a rerun every week or until you are satisfied, and then you let it run forever in inference. One of the most important points of why even do this is this feedback loop. Like you have from here, you have some metrics that a model does not work as intended, is not used as intended. This also happens quite often. Then you can begin with new data or with more data, other data, typical stuff you do when testing models. Or you see on model evaluation, it does not work as intended, or you do not get this value as needed. Then you also give this as a feedback loop in this part, and then you also start with new data or fresh data.
And if you don't want to do that feedback loop, you have like contract work and at the end you finished, never touch it again, then you don't need Kubeflow, right? Because you don't need the reproducibility. You will just say, okay, it was once in prod, I'm done. So that's like a little bit the line where I would draw. Then you use it, or then you don't use it, Kubeflow. Or any other MLOps framework. So, and now, the typical question, I use ChatGPT off the shelf. I don't need that, right? Well, you can too, and sometimes it also makes sense, right? Normally you have also data that you want to add, or just own prompts. You don't need then the training data, right? You will not do a model if you really just say off the shelf, no fine-tuning of a model. You can then just take the data, but then again, you need test data for that as well. And then you need again an evaluation of the model, right? That can just be for updates of a model, or it can also see that you change your prompt, or again, you have like a reg or some data that you will feed to the model, and this will change. So there you have exactly the same loop that you can also do again feedback and say, okay, here I can improve something. And at the end, you can again then serve the model. Maybe you don't need some additional component, depending on how you want to do it, but you need to deploy it anyway and use it there. Again, you want there also the feedback loop and so on.
Yes, this was an example. Maybe if you just want to test your 4 or 5 prompts and look how it performs, I would argue this is overkill. You don't need Kubeflow to have a simple test script of some prompts or some initial data. But when do you use Kubeflow? And I would argue the first question is, do you have Kubernetes? If yes, then probably you can use it. If no, I will not bother with it, because training a team on Kubernetes and Kubeflow is a little bit much. Then also an important point today, it's this slow for rapid prototyping. Like if you're in a proof of concept phase and you just want to test 4 or 5 models, 4 or 5 prompts with some gigabyte of data or so, then you have longer to set up this infrastructure than to do the actual tests. So if machine learning and generative AI is something that you value as your core business, you're already on Kubernetes, and you have some team or some guys that know their infrastructure, then you're ready to go. But it has heavy infrastructure overhead. Just an example, the network layer of Kubeflow is Istio. So, well, it has overhead.
And also a little bit a bad thing, documentation could be improved, right? I think they make good progress, but it's still a way, as in many open source projects.
I deployed quite a lot of these Kubeflow infrastructures for different companies, for different needs, and these are like key lessons maybe to start with. Like, start small. There are a lot of components. You most probably don't need all of them. Start with one that solves your most urgent problems, your highest demand, and then build on it if you need it, but start with something. Then own clusters. I would isolate Kubeflow from other production or even dev clusters, because Kubeflow tries to be unopinionated in the sense that you can use components as you want, but you will install Istio, you will install Knative. Ksurf is also really big, so you have some benefits if you use a dedicated cluster for Kubeflow. Manage Kubernetes, that's more my point. I'm not so into on-prem Kubernetes, so for me it's easier managed, but if you're super good in Kubernetes, then go for it. And the most important part, it's not a magic platform. The stuff we have seen on slide 4 or 5, KPIs, does it solve a problem? This is still super relevant, even with this tool.
And that's, I think, our key takeaway. Yeah, don't throw away what you learned from the classical IT project. It's still necessary and still the beginning for success. And as we see with current MIT studies and so on, sometimes with hyped topics it's thrown away. But keep on this, ask why are we doing it, how do we measure success, and at the end, if we do it, do DevOps, do MLOps, any ops, it solves some problem, but not all. Thanks a lot for listening, and here you find the slides, and maybe we have some question time. Good. Thank you.
Thank you.